Hello, good evening, everyone. So it's a revision class. We started 5 minutes earlier so that we can wait for everyone that that wish to be part of the class to join. Alright, so you can as well share to your friends who want to join as well. I don't know if people can hear me. If you can hear me, please let me know. Seems I can't hear myself, or is it my network? I hope MTN will allow us to do this class. Showing excellent here. Yeah, good evening, Frances. Good evening. Okay, let me. It's showing excellent. And this thing is not capturing it. Okay, I think I can see the charts now. Yeah, Chimeze Mesoma, Oji Manuel, Precious, Felix, sorry, Fidelis, Chinemerem Charles. Okay, thank you, Charles. Esther, good evening. Good evening, you are all welcome. Can you see my board? Can you see my board? I don't know if I'm actually projecting my board. Please, is it my board I'm projecting? Okay, oh no, sorry. Okay, it wasn't my board I was projecting. Let me see if it will show now. Ooh. Let me see. Okay. All right. My board is showing now. Sorry. Okay. Can you see it now? Can you see now? Meanwhile, as you join, remember to fast forward a little bit because your own might be lagging behind. So you need to fast forward to be able to be with us. Okay. So like I said earlier, is it 9? Is 9 already? Okay, maybe I should, I don't know. We are probably just going to work with 1 or 2 or I don't know, depending on our time. Depending on our time, some past questions. So let's see. Okay, so here you can see a past question on the board. You can start attempting it on your own, and then while we I'm supposed to kick off. I don't know if it is immediate. This is a minute past 9, so maybe I will give 2 more minutes, but we started 5 minutes late, so 5 minutes earlier, so we can actually kick off immediately. I'm not sure that would be bad. Okay, so that being said, so I think it's a good, sir, it's not audible. All right, don't worry. As we progress, I'll try to raise my voice as much as I can. Let me see how I can cover that. Yeah, good evening, Gifts. All right, good evening, Emmanuel, I can see. All right. Okay, so let's begin. Now, remember, if you check the description on this video, you will see I tried as much as possible to list some of the topics or all the topics that we covered in the course Math 101 that you are expected you are going to be tested on in tomorrow's exam, right? So your exam starts from morning as early as 8, and then depending on your schedule. I believe everyone should have seen the schedule now, and then you should be able to know your time so that you won't be late. Okay, so let's see. Okay, so let me first of all try to bring out some of the topics. Mark 101 revision. So some of the topics that we saw include types of numbers, that's number systems, and then under number systems we looked at this guy which we called natural numbers. We looked at this guy. Let me immediately form the relationship. So we said, okay, let's start from prime numbers. So we looked at prime numbers. Prime numbers, natural numbers, and then we have set of integers, then we have rational numbers. Rational numbers together with irrational numbers, which is q complement, which we also write as q prime, and then these together inside your real numbers, and then with your real numbers finally inside the biggest set, which we call the complex numbers. All right, so so that was what we did in the first topic. Now remember that we said that this is the first thing you need to take note of, and then the second thing is, when we come in this topic, most can see, as we're going to see in the question here, is that we'll be asking you of their intersection or union or difference. Okay, so for instance, we can ask you to get say R intersection Z, like you can see in question 3 here, right? And then how do you do that? Then we said that all you need to do to be equal to A. That's if it is contained inside B, as we have here. And then if you're looking for union, union looks for the greater one. That's the one containing the other. So, instance, if my A is inside my B, therefore my A union B will be equal to B. Simple. All right, so this was what we did for the topic 1, but then again we are going to use just the questions to run this revision, but I want to list out some of these topics. So remember, we also did set theory as the second topic. The third topic was indices. The fourth was logarithms, and then the SURDS, 5 SURDS. After SURDS we saw quadratic equations, and after quadratic equations we saw polynomials as number 7, polynomials and their factorization, and polynomials and their factorization. And under here we also saw the factor and the theorem, polynomials and their factorization. Okay, and then we also saw factor and remainder theorem. And then after that, I think the next was partial fractions. So we saw partial fractions, then we saw partial fractions, then we also saw sequences and series, sequences and series, sequences and series, and then we also saw series. and then we also saw inequalities. After inequalities, I think we also saw permutation, that's P and C, and then we saw trigonometry, we saw binomial expansion, and finally you have your binomial expansion, and then finally you have your complex numbers. Okay, so this is how you are supposed to have these topics at the tip of your fingers, okay, so that you will be able to know the ones you have mastered and the ones you need to ask questions on in this evening's class. Although we expect that the past questions will cover as much as possible, but let's see. Okay, so we go over to my past question now. So this one starts with the first question here. I hope you can see the questions. Yeah, you're supposed to. The number one says that we should solve. This is a logarithmic expression expected to solve. So we are told to solve log of a squared over bc. Let me write it. Number one, log of a squared, over bc in base a. Am I correct? Yes. And then plus log of b squared over ac in base a as well. And finally log of c squared over, this time around, ab, and that is base a also. So now we are to solve this. To solve is, I expected that the word there should be simplified, not solve, because there is no variable that you are looking for its value. Alright, then let's go. So to simplify this, you are going to apply the laws of logarithm, and we discussed a number of them, but the one that will help us here is the law of addition, which turns into multiplication. Recall that law says multiplication. Recall that law says that if I have log of a base whatever plus log of b base the same thing, let's say base x, all right, that this is the same thing as log of your a times your b, and then to just one of the bases. So if you keep adding logarithms and the bases are the same across, even if you added 10 of them or 20 or 100 and the bases are the same, all you need to do is pick one log and one base and then multiply all the numbers. Remember that the one up is called the number of the log, while the one below is called the base of the log. Okay, so let's apply that to the example we have above. So what do we do now? That's going to give us, let me reduce this. Okay, yeah, so that's going to give us so I'm going to pick one of the logs because the bases are the same, and then I'm going to multiply all these guys up here. They are the numbers. So there I'm going to have a squared over bc multiplied by b squared over ac and multiplied again by c squared over ab. Okay, now what I'm going to do in today's class is I will pick one from the beginning and then I will run down and pick another one from the end, so that we'll be covering both ends. I hope that will be helpful. I wouldn't know, but let's see. If you think that's okay, you can also let me know in the comment section. Okay, so here now we are going to have so you just simplify what you have in there. So of course this is a squared, and you have two a's below, so these two a's, that's a squared here, can cancel this, and this will give me 1, and I will have 1 here. And then again my b squared will also cancel these two b's below, okay? And finally my c squared will cancel the two c's below, and so everything is going to give me 1 1 1 1 1 1 all over 1. And if I multiply out, that's going to be the logarithm of 1 over 1 is equal to 1, and then in base a, and you are done. Of course, there is a rule of logarithm which we know that says that the log of 1 to any base is equal to 0. Alright, and so your answer is 0. So of course, if you come to the options, you will see that there is a 0 in the options, and that is option A. So A is your correct answer. Alright, now I'm going to allow you to do number 2 and 3, attempts number 2 and 3, from what I said earlier about types of numbers. So let me see what you can do with number 2 and 3. Okay, thank you. Yeah, good evening. You're welcome. Kopama of Chelsea said he has the answer. This Kopama, you have told me who you are before, and I've forgotten now. Don't mind me. Alright. Okay. Ada says it's okay to go pick one up, pick one down. So, but let's see. What do you see of number 2? Let me see. Answer for number 2. Let me write it down. N, number 2, we have N union Z intersection Q, union Z intersection Q, then union R, close the bracket, everything intersection P. Okay, so what do you think? What will be your answer here? Let me see your opinion. What's your answer for number 2? It says simplify. Remember I said that, let me go up a little bit, that when you have these types of numbers, depending on how they are inside the order, that P is inside N, N is inside Z, Z is inside Q, and then Q and QC are disjoint. But if you join the both of them together, they are inside R, and then R is inside C. And then I said that if 2, okay, Akamai yourself, you are answering Kopama. Okay, it's alright. So I said that if you are taking intersection, that it gives you the smaller one, that's the one that is inside, and then if you are taking union, it gives you the bigger one. And then to take on number 2. So what do you think of this number 2 question? Number 2. Okay, gift says R. Okay, who again? Okay, Akachuku says P. Precious says P. Frances says R. Okay. So these people that are top fans, how did they get here? Akachuku, you are a top fan number 2. You have not gotten to number 1. Try. Oji Manuel. And I see Frances, top number 1. Oh, beautiful. Okay, Akachuku says P. Oluchi says R. Okay, can we look at them very well? Now, there's something I want you to see, which is very important even in our exam, that you're going to see tomorrow. Some of the questions are going to be very easy, and some might be demanding. Now, you see a question, you need to solve it. The answer is obvious. And what is it? The answer is P. How is it P? Look at it. You don't need to solve this. They gave you a bracket here. Let me use black now. They gave us a bracket here. And then the next thing is intersection P. Now, that means whatever you get from here, you should take its intersection with P. And mind you, that P is the smallest. And so, whatever you get from the bracket, it does not matter. P will still be smaller than it. And so, when you take the intersection of whatever, let's assume it is N. N is bigger than P. If you take the intersection, it will still give you P. Let's assume it is Z. Z is bigger than P. If you take intersection with P, it will still be P. Let's assume it is Q. Q is bigger than P. If you take intersection with P, it will still be P. And so on and so forth. So, but let's assume we want to do it gradually. So what are we expected to do? If you take the union of this and this, Z is bigger than N, that will give you Z. So then you are done. So you take Z and Q, Z intersection Q. Z is smaller than Q, so the intersection will be Z. And then finally, you will take Z union R. And your R is bigger than Z because union looks for bigger one. And so your answer will be R. So from this bracket, you are getting R. Then you will now intersect it with P. And like I said, P is smaller than all of them. And so your answer is going to be P. I hope that makes sense. Did you understand that? Let me get our responses for those that didn't get it correctly and those that didn't respond. Does it make sense? Does it make sense? All right. So as I see your responses, we can go over to number 3. Let me see what you have from number 3. Okay. Okay, number 3, what do we have? Yeah. Ooh, I have a gift from Gift. You see now. Thank you, Gift. Okay, thank you. Okay. Right, so okay. So, yeah, I don't understand. Yes, I get it now. I don't understand. Ijoma, Esther, okay. Alright. Okay. Alright. So what did I say? The summary of everything I've said is this. That if you take the intersection of any two of these sets that we know, 7 of them, P, which is prime numbers, N, natural numbers, Z, integers, Q, rational numbers, R, irrational numbers, and then QC, irrational numbers, then R, real numbers, and our C, complex numbers. If you take the intersection of any two, that it is the same thing as getting the smaller one amongst the two of them. So all you need to do is to master that thing I wrote up there. That's how they relate. And I told you here, look at it, that P is the smallest. It is contained inside N. N is contained inside Z. Z is contained inside Q. Q and QC they don't contain each other. They are disjoint. But both of them are contained inside R. And then R is contained inside Z. So once you can remember this, then all you need to do is to just use that to check. Like the number 3 now, which I asked us to do. Yeah, blessing, you're welcome. The number 3 that I asked us to do, which is R intersection Z, is very obvious. Your R is only small, your C. So it's bigger than Z, it's bigger than Q, it's bigger than QC, it's bigger than all those. So your Z is smaller than it. So the answer here is simply Z. Yeah. Thank you. Yeah, Chinemerum Charles. That's beautiful. Alright, Elijah, yeah, Z. Okay. So that's very correct. So the answer is Z. Okay. Yeah, Fidelis says he does not, or Melody, should be a lady, says she does not understand number 2. So what to have explained it again and again. I don't know if it makes sense now. So I said you should take it 2 at a time. It's a binary operation. So you cannot do all these 4 at once. Please make sure that you fast forward your video to be at the point where I am, so that you can be hearing me at the same time. So I said that you should do 2 at a time. So your N and Z will first of all go. So you will ask yourself, N and Z, they are asking for union. So whenever they are asking for union, they are looking for the bigger one. So you are saying between N and Z, which one is bigger? And the answer is Z, from the numbers or the relationship I gave you above. Your answer here will be Z, because Z is bigger than N. Okay, and then intersection, you now join it with Z, Q. Again, your Q is bigger, intersection is looking for the smaller one, and your Z is still smaller than Q. So the answer here will still be Z. And finally, you union it with R. Union is looking for bigger one, and R is bigger than Z. So you will get R from here. And then you now bring it out and join with this one. So that's R intersection P, which is equal to P, because P is smaller than R. I don't know if I made some sense now. Okay, so if it is better now, so let's go down and then pick a question that is below. Number 33. This one is coming from permutation and combination. Permutation and combination. Ooh, that's too small. Sorry. Okay, so number 33 is coming from permutation and combination. The question says, let me try to read it. Okay, I don't know if you can see it from there now. Okay, number 33. It says, find the number of ways the letters of the word percentage can be arranged if the E's must be next to each other. I remember that we took time to explain this very, very well. Okay, so number 33, find the number of ways the letters of the word percentage. Let's write it. Percentage. The number of ways that the word percentage can be written or arranged. Did they say arranged? Can be arranged, yes. If your e's must be tied together. So if they must stay close to each other. Okay. So remember that whenever you hear arrange, that it talks about permutation. But of course, that doesn't bother us because we are not going to use permutation formula here. We are just going to use our number technique. And what did I say you should do here in this kind of question? All you need to do is, first of all, rearrange it to look like the condition. So E must be tied together is the condition. So E's must be together. Okay. So now you need to rearrange it to look like that condition. So what do we do? So we are going to, okay, yeah, you are making, oh, Amara, thank you, okay. So let's try to rearrange it. So we bring P, then R, then C, then N, then T, then A, then G together. So after that, we'll now bring out our E, that's E1, E2, and E3. So there are 3 E's there, okay? So we will assume that these 3 are together. So they should not leave each other at any point. Yeah, Miss Omazi is correct. You're welcome. Melody, you're welcome. Okay, so now, how do you do it? Now, but before we do this, remember that in our arrangement of alphabets, let's use something like by as example. So if we ask you to get the number of arrangements you can get from the letters of this word, you ask yourself, are the alphabets different? If the answer is yes, then all you need to do is to count the number. So like in this case, you have 3. So this is just going to be 3 factorial. That's your answer. You are done. So once the alphabets are different, just count it and take the factorial. Now, but if there is a repetition, look at this one, like book. So book, there are 4 alphabets there, but a repetition of 1 occurred. Okay, so what do you do? So you are, I love the fact that I'm seeing some answers already. Thank you, Elijah. Akachuku, thank you. Kelechi saying this is our first time of joining. That's beautiful. You are welcome. Okay. Then Frances has an answer. That's very beautiful. Glory, you are welcome. Good evening. Okay. So now let's go on. So if there is a repetition, what did we say we should do? Count the number of alphabets. That will be 4 factorial. Then but you will divide by the factorial of the repetition. So here O repeated 2 times, that will be 2 factorial. Okay, if there's another thing that repeated, you will still put that one and put factorial there. Okay, so let's now come here. So in this case, we are going to count the number. Now we have 1, 2, 3, 4, 5, 6, 7. So there are 7 single digits, and then this one now is tied together. So you are still going to count it as 1. So that means 8 are there all together. So your answer is going to be 8 factorial. Now you are going to multiply. Why are we multiplying? There is something that is tied together. So, but before multiplying, you will check if there is a repetition. Let me remove the multiplication first. So, you will divide and look for a repetition. But no repetition occurred here. So, I'm going to remove the division sign. So I'll remove it since there is no repetition. Then I will now multiply by the arrangement of the ones that you tied together. And the ones we tied are 3 alphabets. So that will be 3 factorial all over. You will also check if there are repetitions inside the one you tied. And yes, the 3 alphabets actually repeated. So that factorial again. And of course, 3 factorial over 3 factorial is 1. So your answer is 8 factorial. Now, if we come to our options, so your options should tell you what to do. Some of you that gave me answers by expanding, you see that we don't need to expand. Okay? Like Elijah gave me 40,320. Jessica gave me 6,720, and so on. Frances, the same thing. So I don't know how you got that. Maybe you expanded. So you don't need to expand because you can clearly see that the question does not require expansion. Okay, so all you needed to do is to leave it in the factorial form, and that's enough. So our answer is actually option B. I hope you can see it. Option B is your 8th factorial. All right, I hope that makes sense. Okay, sorry, I had to expand it a little bit. Sorry about that. Okay, so your answer is option B. Okay, and which of them is in the expanded one? Is it the 40,000? You can't see it. Sorry, I've removed the board. Let me expand it more. Okay, so option B. Okay, I think it's actually clearer here. Okay, so any question on that? I think is clear. Frances, can you see it now? Why did you divide book? Okay, I divided book because there is a repetition of O 2 times. Melody, your O repeated 2 times, and so you will divide by the factorial of the repetition. So since O repeated 2 times, so that will be all over 2 factorial. I hope that is understood, and that's why my answer here, you are going to see that when I did for E, that's E into 3, I had 3 factorial. I still divided by 3 factorial because there is a repetition there. Melody, I hope that makes sense. Okay, so, and that's for number 33. Now let's go on to the next one. The next one is let me see if we can do number 32. Oh, okay. I wouldn't like to do that one now before we okay, it's not bad, Sha, but it will. Okay, let's go up. Let me go up a little bit. Okay, so on coming up now, we want to look at number 4. Let's go to number 4. Okay, number 4 there. Okay, Kelly Lucy is saying, why do we have 3 factorials over 3? I think I explained that in that one you have 3 digits. Sorry, 3 alphabets. That's E into 3. So that is the 3 factorial up. Then you also ask yourself, is there a repetition? And the answer is yes. Your E repeated 3 times. So, and that is the 3 factorial you have below. The repetition is used to divide. Then the normal counting is always on top. Right, Lucy, I hope that makes some sense. Yeah, Evangeline, yes, you will have the record. Immediately the class ends, I will publish the record and you can see it on the channel as well. All right, okay, so let's go over to our number 4. Number 4 is from the topic indices. Let me try to write it down. It says solve for x if let me increase it. Yeah, solve for x if 6 raised to the power of x multiplied by 9 raised to the power of x minus 1 times 4 raised to the power of x minus 1 is equal to 6. Oh my God. Let me try to write it down. Number 4, solve for x if 6 raised to the power of x times 9 raised to the power of x minus 1 times 4 raised to the power of x minus 1 equal to 6. Okay, let me try to put out the options so that we can have it here. A is option A is 6. I think this one is actually more visible, so I shouldn't really bother, but since I've started, let me write. Option B is 3. Option C is 2. Option D is, I think, 1. Yeah, 1. And you know our E is none of the above. Okay, so let's start. What do we do there? Okay, yeah, Jude, welcome. Yeah, Lucy, that's beautiful. All right, so what do we do here? So we will try to see how we can remember that it is in your power that your x is contained. So you will need to look for a way to make the basis to be the same if it is possible. Or watch out what we have here. The power here is the same as the power here. And you know that if I have something like, let's say, 2 to the power of 3 times, or let me say to the power of x, times 3 to the power of x, or let me put it this way. Let me start from the way the rule is stated. You recall that if you have a times b raised to the power of x, that this is equal to a to the power of x times b to the power of x. So that means if you now give me something like this, I can actually write it in this form. So if you give me 2 to the power of x times 3 to the power of x, the powers are the same. So I can actually factorize out the power and multiply the basis. I hope you understand what I am trying to do now. So I can actually come here, return my 6 to the power of x, but for this one, since the powers are the same, I'm going to put the two of them into a bracket and then pick only one power. I will pick only one power, and then that is equal to my 6. So watch what we are going to do there. So you just multiply what you have in the bracket. Okay, someone, he has removed it. Elijah. All right. Mommy Lucia is following. Oh. Okay. You're welcome. You're welcome. All right. Is that my friend? You know you did not tell me your name. How is my baby doing? Okay. So let's go on. So this is 6 to the power of x. Now if we multiply 9 by 4, that's going to give us 36. In fact, I don't need the bracket again. So you will have 36 to the power of x minus 1. And that is equal to 6. Now follow me. See what is going to happen now. All of them, we can write them in the same base. So I have 36. So I can write 6 to the power 6 times 36 is the same thing as 6 to the power of 2. And then that 2 will multiply your x minus 1, and that is equal to my 6 to the power of 1. So everything now is in base 6. So I can now apply the law of indices. Okay, the law that says that multiplication will change to addition. So we'll pick one base on the left hand side, that's 6, and that is raised to the power of x. Then here you have plus 2 into x minus 1. So your multiplication will change to sum of the powers, and that is equal to 6 to the power of 1. So immediately the equal bases will cancel out, and so I will just have x plus 2 times x minus 1 equal to 1. So just open your bracket. That will be x plus 2 times x is 2x, 2 times minus 1 is minus 2, equal to 1. Then collect like terms. X plus 2x is 3x. Then minus 2 will come over. Okay, someone says 1. That's Pascal. And Frances says the same thing. Okay, yeah. Well done. Okay. J Black says 2 over 3. Okay, look at it very well. I think we already seen the answer. The answer will be 1. So because minus 2 coming over will become plus 2. And that will give you 3. So divide both sides by 3. And so our x is equal to 1. Our x is actually equal to 1. I hope it makes sense. I hope it makes sense. Evangeline, you're welcome. Maybe it's fine. Okay. Okay. You're welcome, ma. Alright. So, this number 4. I mean 3. Yeah, 4. Did it make sense? And we have option 1 here. That's D. Okay. Did it make sense? Any question? Alright. J Black, well done. Okay. So, and I'm going to allow you to try number 5. Number 5 is going to be an attempt from you. Let's see. Number 5, you have 2 raised to the power a plus 2 raised to the power of a minus 1 equal to 3. So can we try this one? We are looking for a. Okay, let's go ahead. Okay. Someone is asking for options. A is 1. B is 2, C 3. Okay. Let me leave the question open. So the question is here. A is 1. B is 2. C is 3. D is half. Okay. Okay, I'm receiving answers. Okay. 1 1 1 1 1 1. Beautiful, beautiful. Nice job. Thank you, Amma. Okay. 1 1 1. Okay. Hi everyone. You're welcome. Chivik. Okay, gift says 0, but there's no 0 in the option. Can you check again? Okay, Kopama says 0, Esther 0, Oluchi 1. Sorry, Esther 1, Oluchi 1, Ifechu 1, Precious. Okay, alright. So let's try to do it together, everyone. So what do? Always learn to apply your rule. So first is to notice that here you have subtraction of powers. And you know that subtraction of powers is gotten from division. Addition of powers is gotten from multiplication, while subtraction is gotten from division. So the meaning is that originally this person had 2 raised to power a all over 2 raised to power 1, and that is equal to 3. So what do? Try to clear the denominator. Remember that 2 raised to power 1 is 2. So to clear the denominator, multiply through by 2. So I'll multiply here by 2, multiply here by 2, and multiply here by 2. If I do that, these 2 here, we cancel this. And then I can give my 2 raised to power a name. I can say let 2 raised to power a be equal to x. If I do that, so this now will become 2x. And then this one will become only x. And finally, the right hand side is equal to 6. So 2x plus x is 3x equal to 6. And so your x is equal to 2. Do we get that? So you now come back here. Remember, it's not x you're looking for. You're actually looking for a. So you now substitute. Your 2 raised to power a is equal to 2. Okay? And you know that 2 is the same as 2 raised to power 1. So by the time you cancel equal basis, I love my class. I love my class. I love to teach my class. I really love to teach this class. So I love the answers. So the answer is again equal to 1, which is A. Alright, and I have Jessica. Jessica says she's confused a little bit. Okay, so Jessica, one says confusion. Okay, Ijama is confused as well. E no go better for network, I dey tell you. No mind them, yeah people. Okay, so where did you get confused? Let me ask. Okay, gift. Can one of you just drop quickly? Where did you get confused? Where? But why I got the answer, but this not this way? Of course, it's possible. Of course, it's possible. You can do that. But I wonder how you did it. I wonder. Wonder. You can do trial and error, sha. Trial and error can work here. Lucy, I combined division law and then yeah, it's basically division law. That's what I used by changing. Remember we said that if you have a to the power of x divided by, let me use all over a to the power of y, once the bases are the same, that it is equal to a to the power of x minus y. So I now went in the opposite direction, in the sense that if you give me a to the power of x minus y, I can write it as a to the power of x all over a to the power of y. So that's what we did up there. We were given 2 to the power of a minus 1. So we now wrote it as 2 to the power of a all over 2 to the power of 1. Are we following now? I'm trying to explain again. Okay, so yes, Frances, imputing the options is going to be beautiful. It will help. Yes, it will help. But then, if you know how to solve it, it can actually be faster. For someone like me, I may not need to put the options, but that is very perfect. You are allowed to do that. Yes, you are allowed to do that. If you put your options and you are lucky that option A is the answer. If you put your 1 here, that will give you 2 raised to power 1 plus 2 raised to power 1 minus 1, which is 0. And 2 raised to power 1 is 2. 2 raised to power 0 is 1, and that's equal to 3. So that is very correct. Okay, is allowed. You can do that. So everyone, maybe you can try that approach tomorrow. You can try substituting the options to see what you will get. Okay, so now, yeah, Amara, yes, it will be. So I don't know, mine led me to quadratic equation. No, it's not supposed to go to quadratic equation. If you do it very well, it will not lead to quadratic equation, because there is no power here that should make it to go to quadratic equation. Did you get that? It shouldn't. Okay, so all you needed to do is, by the time you have changed this to 2 raised to power a all over 2 raised to power 1, which is 2, you just remove the denominator. Whenever you have a denominator, you're solving a problem, it's always advisable to remove the denominator. Try it. It would always help you. So to remove the denominator, you don't just throw it away. You will multiply through by that denominator, and it will give you something that will cancel out. So if I multiply through by 2, multiply here by 2, and multiply here, because in maths you should do it across all the terms. So this will now cancel this. This one will become 6. So ordinarily, what we should have gotten is we should have gotten our 2 times a raised to power 2 plus 2 raised to power a equal to 6. Then you now need to substitute, or you can still use your senses and look at it. This one is 2 a raised to power 2, while this one is 1. So if you join it, you will get 3. If you don't want to substitute, but substituting will be better. Alright, so let's go to the next question. I think I want to follow sequentially now again. Number 6. I want you to try number 6. Everybody. Yeah, Claire, I will do that. Try number 2, everybody. Number 2, you're looking at, let me see, if x is equal to log y base 4, express log 16 base 4 in terms of x. Okay, that's number 6. My x is equal to log y base 4. So they are asking us to express log, where is it? Log 64 base y in terms of